Welcome to Stories from the NNI. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Today it's my pleasure to welcome Jamey Wetmore, Associate Professor in the School for the Future of Innovation in Society and Co-Director of the Center for Engagement and Training in Science and Society at Arizona State University. He is also Associate Director for Societal and Ethical Implications of the National Nanotechnology Coordinated Infrastructure Network funded by the National Science Foundation. Jamey, thank you so much for joining us today. To get us started, can you tell us a little bit about yourself and how you got involved in nanotechnology?
Actually, I was a postdoc studying technology and ethics at the University of Virginia when I got a great opportunity to join as a postdoc at Arizona State University. At the time, it was called the Consortium for Science Policy and Outcomes, and they had just gone through basically a year-long process applying for what became known as ASU's Center for Nanotechnology and Society. So I actually got kind of the benefit. They already applied for the grant. I arrived, and a month later they got the grant, and then they're like, hey, we've got some work for you to do. And so next thing I knew, I was in charge of one of the thematic research clusters for the project called Equity, Equality, and Responsibility. And our job was to look across everything the center was doing and have conversations and get everyone involved in thinking more about the responsibility issues and quality issues that they were studying.
So, the National Nanotechnology Coordinated Infrastructure, or NNCI, is a network of user facilities and nodes across the country. And you're at the Nanotechnology Collaborative Infrastructure Southwest, or NCI Southwest, which is part of this national network. Can you tell us a little bit about your node and what your role is there?
Sure. So the NCI Southwest, when they built the NNCI, the idea was to have nodes across the country so that a researcher anywhere in the country wouldn't have to travel too far to get to a lab that they could use. And so we are the representatives of the Southwest of the United States, and actually we stretch across most of the state of Arizona, which makes us not too far from people in Utah and New Mexico and Colorado, things like that. But we do specialize in some things. Each of the nodes in the network has a different specialty or brings different things to the table. And so because we're in the Southwest, because we're in the middle of the desert, we bring things like a solar power lab. So if you want to create some small prototype solar cells, or actually I think one thing that we can do is even figure out how to ramp up production and those kinds of things. One of the other things that we have is the life cycle and nanotechnology analysis group. And so they're really looking at not just production, but the full life cycle of nanotechnology, which sort of is, I think, an increasingly important way to think about nanotechnology. And the other thing we do is we have the Societal and Ethical Implications group at ASU as well. So we have a number of people that had been trained and worked with the Center for Nano Society that I was just talking about. We are inviting people from anywhere, actually. I was going to say across the nation, but we actually have people from around the world come to visit us who are working on a project and want to think more deeply about some of the implications of that project, how it might impact society, how it might affect society. And we have a number of different tools that we use to help people think about possible futures and ways to shape our presence to get us closer to the futures we might want to have.
So, can you tell us how your node works with the other nodes in the network and what your role is as the associate director for societal and ethical implications?
Yeah, good question. So the chart that explains how the network works is pretty complicated. And I don't know if anybody's ever actually written it down. But there is this idea that because we have these nodes all across the US, each of them sort of working independently, but we come together to help each other out through various projects. So one of the things that's happened recently with the COVID-19 issue, how are you dealing with labs that you have to shut down? What are the decisions you're making to help you decide whether and when to open up? You can decide these things as individual universities or individual PIs working at universities. But when we have the strength of the network, we can have those conversations on a regular basis about what is the best way to do this? What are you guys doing there? What are you hearing from your administration? And I think all of us feel better about how to move forward because we're having these bigger conversations. So all of the different nodes in the network, I think, really benefit from that. I have a slightly weird role, so I'm in charge of societal and ethical implications at ASU and at the NCI Southwest, but then also through the coordinating office, which oversees the entire network. And most of the people that do that work are at Georgia Tech, and so I get to have frequent conversations with my colleagues at Georgia Tech. But what I try to do is coordinate and get people thinking about societal and ethical implications across the network. And we have 4 different universities that are really focused on SEI. So I've got colleagues at NC State and Georgia Tech and University of Texas at Austin who have funding and are doing work in SEI. And then the 4 of us work to try to make sure that those projects get integrated across the network. So for instance, in January, when we were still able to travel, I spent some time up at Oregon State because they were really interested in what the kinds of things I was doing and wanted to make sure their graduate students were getting some of that information and involved in some of those ideas. And so I spent a couple days in Oregon State working with graduate students to help them think about the ethical implications of their work and how they might think about their future careers as well.
So you mentioned working across the nodes and collaborating, but can you share your thoughts on collaborating across disciplines and bringing folks with different backgrounds together to advance nanotechnology?
It's interesting, the kind of tools that I have. So I'm trained in a variety of weird things like sociology and anthropology and political science and philosophy. I can really study and work with just about any technology, and I do. Some of my work is focused on, actually, I study the Amish use of technology, and I look at how religions interface with technology. But it's interesting that nanotechnology, it really drew me to it because I found it inherently interdisciplinary. I think from the very beginning, the people working on nano realized that no single discipline was really going to make the advances that they wanted, that you actually had to bring together people from different disciplines. And to this day, that keeps me excited and wanting to work with nanotechnology and people who do nanotechnology.
In the Center for Engagement and Training in Science and Society, you talk about or engage with the public. Why is that important?
Well, there's a couple of reasons. I think scientists and engineers engaging with the public is incredibly important, and the public engaging with scientists and engineers is incredibly important. And there's slightly different reasons. For the public, I think, first of all, the public isn't as naive, I think, as a lot of scientists and engineers think. Of course, scientists and engineers have to remember that they're part of the public as well. So at least some section of the public isn't naive. I think that many members of the public really do think about the big picture and the world that they want to live in. And they realize that science and engineering are going to have a profound impact on that world that they're going to live in. And justifiably, I think they want to say, or they at least want to understand how this is going to happen and how this might impact them. One of the most amazing scenarios I was ever a part of, I was working with a graduate student who, for his PhD, he washed socks. He washed socks that had nanosilver particles in them. And his question at the time was basically, how much nanosilver comes out of these socks? How long might these socks actually keep the nanosilver in them? And we ended up setting him up at the Arizona Science Center to demonstrate his project. And we sat in a dark room most of the day, and he was watching socks. He was letting kids come up and wash socks, and then he would explain to them what was going on and the antimicrobial properties of the nanosilver and why this was all being done. And at one point in those discussions, a mother looked at him while her daughter was washing socks, looked up at him and said, "What happens to the silver after it washes out of the socks?" And he hadn't thought about that question before. And she was reasonably concerned. She was like, this is going to go somewhere, and not just where is it going to go, but how is it going to impact my daughter and her future? And that turned something on in his brain. And he all of a sudden realized, oh my God, I'm thinking about this in a way too focused way. I need to think about this in a much bigger way. And that student ended up doing a huge amount of work. Again, where it goes, what the impacts on aquatic life might be, and what the impacts on waste management might be. And in the end, his work ends up getting cited in EPA regulations. And it was, I think, not completely, but a huge part of that was that one conversation. A member of the public asking what, might be a naive question ended up being a profoundly important question. And he needed that perspective in order to understand how he could really apply his engineering knowledge to benefit the world.
So, looking back over the past decade or two, where do you think nanotechnology has had some of the most significant advances?
I think there have been a number of advances, but nanotechnology has achieved something really interesting. I think it's becoming invisible. Nanotechnology is becoming so important that it no longer gets singled out quite the way that it used to be. It's now becoming fully integrated in so many different disciplines. So, in some sense, it's almost like computing. Physicists, well, not all physicists, but certainly some physicists don't describe their work as computing work, but it wouldn't be possible without computing. And so I think nanotechnology is in a similar way. Its achievement is that it's become so important that we don't necessarily single it out anymore. It's just a part of the fabric of the way we do science and engineering.
Thank you for taking the time to talk with us today. Do you have any closing thoughts that you would like to share with our listeners?
One thing that I find I do a lot of work with graduate students in science and engineering, and nearly all of them started their work because they wanted to make a difference in this world. And they've learned over time that science and engineering does have a profound impact on that world. I think the thing that they're often coming to grasp with when they're graduate students is that science and engineering in and of itself doesn't change the world. It's taking those knowledge and applying it and integrating it into society. And I think the more scientists and engineers know about the process by which their work gets integrated into society, the better chance they have of having a positive impact on the world, and to make sure that the technology accomplishes what they hoped it would when they originally thought about it.
Thank you for joining us today for the stories from the NNI. If you would like to learn more about nanotechnology, please visit nano.gov or email us at info@nnco.nano.gov and check back here for more stories.